Okay, so we'll start with the new chapter show,
Yeah.
the
I just
chapter number
want,
3. Yes, yes, yes. Are you
uh,
having any doubts in the previous chapter?
yeah, I just had one question regarding the homework.
Okay, we'll do one thing. So we'll take the class today, and then at towards the end of the class, you can ask me your doubts. Is that fine?
Yeah, yeah,
Okay. So uh, uh, this chapter name is if else. So I'll explain to you what is if else first. If and else are keywords of C language. So the if block is used to check the validity of some condition. So the if block checks whether a particular condition is true or false. Okay,
uh,
true or false. Yes. Okay. Now, so the syntax of the if else block is as follows. So I'll show you the syntax of the if else block. I have the if block here. Then I have a condition, and then I have a set of statements here. Set of statements. So how does this run? One more thing. I will be writing the else block here. Inside the else block also I will be writing some set of statements. Okay. Now keep in mind, Shubh, this is just a word I have written. A set of statements means that it can include any a set of statements of C language. Okay, Shubh? Okay, it can
yeah,
be any statement. So now here I'll write, suppose the condition of the if block is true, then the set of statements inside the body of the if block are executed, and what will happen, and the set of statements inside the body of the else block are not executed. Shubh, okay.
yeah,
The condition of the if block is true. Obviously what will happen, whatever statements I have written inside the body, that is inside the curly brackets of the if
of
block,
it.
will be
Yeah,
executed, and the set of statements which I have written inside the body of the else block will not be executed. That is, inside these curly bracket, they will not be executed if the condition of the if block is true. Shubh, okay.
yeah,
I will mention one more point below. Suppose the condition of the if block is false now. Then the set of statements inside the body of the if block are not executed, and the set of statements inside the body of the else block are executed. Okay, sure.
yeah,
So in case the condition of the if block is false, then in that case what will happen, the set of statements in the if block will not execute, that is the set of statements whichever they are, and the set of statements inside the else block will execute, that is the set of statements. Okay, sure.
yeah.
Okay, so we'll do a simple program on this first, and then we can proceed with the more advanced concepts in this chapter. So program to find whether the entered number is even or odd. Okay, so obviously we'll need to include the header file first, stdio.h. I'll define the main function. So I have already explained to you this, that
Yeah.
every C program must contain the main function definition. We have mentioned int as the return type of the main function definition. So it means we can return an integer value from the body of the main function definition. Hence I have return the statement return 0, and I will not get any error for this statement because 0 is an integer value and I have mentioned int as the return type. Understood, Shub?
Yeah.
As I already told you in the previous lecture that the general convention is that when we return 1, it means unsuccessful execution, and when we return 0, it means successful execution. Shub, okay?
Yeah.
I will declare a variable no now. You can use any variable name. I have just declared it no. You can use no1, whatever you want. You can even use a, b, c, d. So variable names can be, you don't need to have specific variable names as such. But obviously there are some rules to be followed while declaring variables. Like you can't use any other special character apart from underscore symbol should. And variable name must always begin with an alphabet or an underscore, but it cannot begin with a digit show digit. Okay.
Yeah.
So for example, if I write a variable name no underscore 1, this is fine. Okay, so a variable name, this is correct. See, because a variable name can, as I told you, contain digits also, letters, alphabets, any special symbols. No special symbol apart from underscore. Okay, so this name is correct. But what if I write 1 no1 for 1 no? Now this is wrong because the variable name can never begin with a digit show. Okay, clear?
Yeah.
If you write underscore no1, this is correct because variable name can start with an underscore. Okay, Shub? And one more
Yeah.
thing, if I write no question mark 1 now or exclamation 1, this is wrong again because as I told you, the variable name cannot contain any other special character apart from underscore. Clear, Shub?
Yeah.
If you want this point, I'll just mention it in a separate notepad file so that it stays with you. That rules for writing variable names. First is variable names can contain alphabets, that is upper or lower case. Then they can contain digits or underscore. Okay, underscores. Second, underscore is the only special character which can be present in a variable. Clear, so?
Yeah.
Third, uh, in a variable name. Okay, now third, uh, we cannot start a variable name with a digit, that is 0 to 9. Fourth, but we are allowed to start a variable name using the underscore symbol or using any uppercase or lowercase alphabet. Understood, sir?
Yeah.
Okay, so this should be case and underscore. Okay. And one more point, this is not a rule actually, it's just a convention that generally we must always try to use logical variable names. Logical variable names in the program. What does that mean? Which give us an idea of what value is the variable storing. Understood, Shub?
Yeah.
For example, suppose we want to store the length and breadth of a rectangle, then the most convenient variable names for readability purposes is length and breadth. Should clear na?
Yeah.
Okay. And sixth, again it's not a rule, it's a convention that variable names can have any number of characters, but generally we don't declare or use variable names with more than 32 characters in it. Clear na? Okay.
Yeah.
So obviously no one will declare a variable name with even 32 characters, because generally we declare variable name with at the most 7 8 characters. So or we can say at the most 10 characters. Is that fine now?
Yeah.
Okay. Okay, so this is just for extra information. This is not this won't be useful at all when you are writing the programs and all. But obviously for other things it will be useful. Like if suppose someone else uh, later on wants to read your C program, which is called as the documentation of the C program, documentation purpose and all. So I hope this is clear. So understood.
Yes.
And one more point I'll mention: these same rules mentioned above for declaring variables must also be followed for declaring user defined constants, then we can say user defined functions, etc. Clear? So and other user defined entities in the C program. Clear? So
Mhm.
okay, so and one more thing actually, but generally constants are defined in uppercase. Again, this is not a rule, it's a convention. So okay, which means if you don't follow that this point also, you will not get an error, that is constant defined in uppercase. It is just a convention. Okay, so
Yeah.
and generally the variable names are defined in lowercase or declared in lowercase. Okay, so again this is not a rule, it's just a convention. Okay, so what I'll do, Shub, that today at the end of the class I'll send you this file also along with the other files which I'll send you today. Okay,
Yeah.
here what I need to do, I have declared a variable no, so let me write printf enter the number. Now I need to accept the input value from the user and no, obviously, because without accepting any input value, how can I check whether it is even or odd or perform any operation on it? Now here I will be using a if block. I will be writing an if block and I will be declaring, or rather I will be using the condition of this if block as no modulus 2 is equal to 0 should. So I will explain to you, don't worry. First let
Yeah.
me finish the program. Printf number is even, and in the else block I can write printf number is odd. Okay, so first of all, what have I done in that condition? Let me tell you. See, this condition is using a new operator which we have not studied up till now. So I will be explaining it to you now. That is called is equal to operator. Okay, so
Yeah.
when you see, always remember when I use only one equal to symbol. Suppose I write A is equal to B. So what does this mean? This is called as the assignment operator. So assignment operator means that I am assigning the value of the variable B to the variable A on the LHS. Understood, Shub?
Yeah.
Okay, so here, uh, suppose B is 5. Suppose B is 5. Then after execute, I'll just write in the above statement we have mentioned only one is equal to symbol. So this is equal to is called as the assignment operator. So A is equal to B will assign the value of the variable B to the variable A. Understood, Shub?
Yeah.
Now, so after the execution of the statement A is equal to B, value of the variable A also will be 5. Okay, which was the value of the variable B, Shub. Okay.
Yeah.
I forgot to add this point here. So I'll do one thing, I'll cut this here and uh, this one. So now it will be, suppose the value of the variable B is 5, then after this is repeated 2 times, so I'll remove this part. After execution of the statement A is equal to B, A also will be 5. Now what is A is equal to B? See, Here I have used 2 is equal to operator show. So this is equal to is not called assignment operator. It is called as the equality comparison operator. So the equal to operator, which is the equality comparison operator, will compare the values of the LHS and the RHS variable and check whether they are equal or not. Understood? Shub? So
Yeah.
if the values of A and B are equal, then A is equal to B returns true. Else, if the values of A and B are not equal, then it will return false. Okay. So I'll mention the point. Here we have used two is equal to symbols. So this is equal to is called as the equality comparison operator and not the assignment operator. So A is equal to B will compare the values of the variables A and B and check whether they are equal or not. If values of the variables A and B are equal, then A is equal to B returns true. Else, if the values of A and B variables are not equal, then A is equal to B returns false. Clear, Shuk?
Yeah.
So example, if I write int A is 5 and B is equal to 5, so now int B is equal to 5. So if I write A is equal to B returns which value? No, true value. Clear, Shuk? Okay, Shuk, clear na?
Yes.
Similarly, if I write, I'll put it as another example, int A is 5 and int B is 6. So if I write A is equal to B now returns which value? False value, because the values of A and B are not equal now. Okay.
Yeah.
Similarly, we can have one more operator called the not equal to operator. So its symbol is like this: A not equal to B. So this is called as the not equal to operator. So this
Yeah.
works in an exactly opposite manner than the equal to operator. So here, what will happen? Tell me, if the values of A and B are equal. Okay, if the values of A and B are equal, so then A is equal to B returns true, but A not equal to B returns false in that case. Okay, so
Yeah.
okay, and if the values of A and B are uh, uh, as I told you, if they are not equal, if the values of A and B are not equal, then what will happen? Tell me, A is equal to B returns false,
False.
but
Yeah.
A not equal to B will return true. Have you understood, Shuk?
Yes.
So I'll just write here the above operator, uh, whose symbol is this, is called as the not equal to operator. This operator works. This operator works exactly opposite to A is equal to B. So suppose the values of the variables A and B are not equal, then A is equal to B returns false, but A not equal to B returns true. Similarly, if the values of A and B are equal now, then A is equal to B returns true and A not equal to B returns false. Clear, Shu?
Yeah.
Okay. So now I will come to back to the program now. See, in this condition, what I'm doing in this if block condition, I am first checking what is the remainder obtained after dividing the numerator NO, or we can say in more mathematical terms the dividend NO by the divisor 2. Then I'm checking whether this remainder is 0 or not. Sure. Okay, sure.
Yeah.
So why I'm comparing the remainder with 0? Because as you already must be knowing that even numbers are divisible by 2. Okay, sweetheart,
Yeah.
even numbers are divisible by 2. हाँ, तो है. हाँ, even numbers are divisible by 2. So what does it mean that they are divisible by 2? That when you divide by 2, you will get the remainder as 0 should. Am I right?
Yeah.
So I'll mention the point. Your key uh, even numbers are divisible by 2, that is when you divide an even number by 2 we get remainder as 0, and when we divide an odd number by 2 we don't get the remainder as 0 because odd numbers are not divisible by 2. So
Yeah.
in the condition that is no modulus 2 is equal to 0, which we mentioned in the if block, suppose the value of the no variable is even, then what will happen? Then the remainder obtained after dividing the value of the no variable. So when I am writing no variable, it doesn't mean no variable. The name of the variable is no. Okay. So
Yeah.
ठीक है. So after dividing value of the no variable by 2 is 0. So then the condition that is no modulus 2 is equal to 0 of the if block will be true, and then the number is displayed as some even number inside the if block. Clear, should?
Yeah.
And suppose the value of the no variable is odd, then what will happen? Obviously then the if block condition that is no modulus 2 is equal to 0 is false, then the else block is executed and the number is displayed as odd should. Have you understood now? Definitely.
Yes.
Okay, so I'll run this program. Before running the program, what I'll do, I will save this program and I will also save another version of the program where I have not mentioned the comment, so it will be easier for you to read the program. Okay, so I think it was the chapter 3 if else block. Okay, so I'll just save it as a program number 1.c. As I told you, I'll save another version of this program 1_1.c where I will remove the comment should. Is that fine, should?
Yeah.
Okay, so I think one big comment was here. So when you read the program, you can easily make out what is the program. And already I have saved a version of the file with the comments, so don't worry. Okay,
Okay.
okay. And these comments also I don't need as of now because this is there in the previous version, okay, or previous copy of the program. Okay, so I'll go to online GDB now. Let us run the program. So yeah, online C compiler. I'll select the program first. It was the this file. Okay, this was. I'll save this file also. So what I'll do, this file I'll save it in the chapter 1 show. Is that fine?
Yeah.
Because it's related to chapter 1. So I'll just write a naming rules for, or not rules also, naming conventions, and it also includes some rules also, and rules for variables. Okay, variables and constants and functions also. Okay, okay. So this I'll close it now and let us copy our program code now, which I have written here. Let me run the program, then you can copy this program yourself. Okay. Okay, so we'll just see whether we are getting the successful output or not. Okay, now if I enter the number as 5, I have got the answer as odd. Okay, that is correct now. Now let me check for even also. So if I enter the number as 6, okay, so number is even. Is it clear, Shub? Okay.
Yes.
Okay. So I'll keep the window open. Could you write this program, Shub?
Yeah.
Okay. And when you finish, just tell me. I'm waiting here only. Okay? Hmm? There's a
Yes, done.
have you finished too?
Yes.
We'll proceed with the next one. Just give me 1 minute, Shubha.
Yeah.
Hello, Shubha.
Yes.
Okay, we'll proceed with the next program now. So I'll save this program now and as program 2 now. Okay. So before that, I'll teach you a new concept now, first of all. That is called logical operators in C language. So here, see what is logical operators in C language. I'll tell you now. So now suppose Shubh, I want to combine multiple conditions, okay, or I want to check the validity of multiple conditions uh, with the help of the same if block, Shubh. Okay, so using the same if block, suppose I want to check for the validity of multiple conditions. So in that case, we will use something called as the logical operator. Okay, Shubh? Logical operator. So
Yeah.
see, in the previous program which we did, I checked the validity of only one condition, which was this. That is, when I divide NO by 2, am I getting the remainder 0 or not? But in real life, you may be having multiple conditions, and either if one of those, any one of those conditions is true, or all conditions must be true. So based on that, we will need to execute a sequence of tasks accordingly. Sure. Okay. So in that case, when we write our C program where we are using an if else block, then to suppose I want to combine multiple conditions in the same if block, or I want to check the validity of multiple conditions in the same if block, then th- then to suppose I want to combine those conditions. So in that case, I will use the concept of logical operators. Okay, clear?
Yeah.
Okay, so I'll just mention one point here, that the logical operators are mainly used to um, when we want to write an if block which checks the validity of multiple conditions. So to when we use the multiple conditions, then to combine those multiple conditions together, we use the logical operators concept. Okay, So there are three types of logical operators. We'll discuss all three of them in detail now. So there are three types of logical operators. Okay. So the first logical operator is the AND operator. So I will write something called as the truth table now. Truth table of the AND op. So what does the truth table mean? See, suppose I'm given a condition 1 and I'm given a condition 2. Okay, and I apply the AND operator between them. So result of applying the AND. So based on what is the value of condition 1 and 2, what will be the result of applying the AND operator between the two conditions? So if condition 1 is true and condition 2 is also true, then the result will be true. So okay,
Yeah.
if condition 1 is true, this is false, then the result is false. Have you understood? True and false gives false. Okay, so
Yeah.
clearly if I'm having false and true, that is condition 1 is false, condition 2 is true, then again I get false. And if I have false and false again, that will also give me false. So see this now if you check here, you will find one very interesting thing regarding the AND operator. Okay, so the interesting thing regarding the AND operator is that
True and both
only
would.
if both the conditions are true, then the result will be true. But if any one of the condition is false, then the result will always be false. Have you understood, Shu?
Yeah.
So now see, let me give you one example of this also. Like for example, suppose was see, so suppose we are having one student, for example, who's studying in a school. Okay, so the rule says that that for any student and who's studying in any standard of the school. Okay, so for any student who's studying in any standard or in any division of the school, that student can go to the next standard only if his aggregate percentage is above 50%, say, and at the same time the attendance of that student must be above 70%. Sure. Okay, so in this case
Yeah.
what will happen, that both the conditions must be satisfied. That is, the aggregate percentage of the student must be above 50%, and the average attendance of the student must be above 70%. So if any one of the conditions is false, then obviously that student must not be allowed to be sent to the next standard. Okay, so in that case we'll need to use an AND operator to combine the two conditions. Is it clear now? Sure.
Yeah.
Okay. So I'll just mention one point about the AND. When we apply the AND logical operator between two conditions as shown in the above truth table, if both the conditions are false, are true, sorry, then only the result will be true. And if any one of the conditions is false, then the result of applying the AND operator between the two conditions is also false. Have you understood, sir?
Yeah.
Then second operator is the OR operator. So OR operator works exactly opposite as compared to the AND operator. So what I'll do to save time, I'll just write OR here. Now the symbol of this OR operator is like this. Okay, have you understood? This is the symbol of the OR
Yeah.
operator. Okay, we can call them two. These are called actually piped operators. Piped means these keys on the keyboard, they are called as pipes. Okay, sure.
Okay.
So we can say that two vertical bars is the symbol for OR operator. So I'll write the truth table for OR now. True or false will give me true. False or true will give me again true here. and false or false gives me false. So as you can see, the interesting thing about the or operator is that here, when even if one of the operands or even if one of the conditions is true, then the result of applying the or will be true, Shubh, okay? And only when both the conditions is false, the result will be false. Is it clear now?
Yeah.
Exactly opposite to the AND operator, because in the AND operator, if any one of the condition was false, we got the result as false. But here, if any one of the condition is true, we will get the result as true, and only when both are false we get the result as false in case of the or operator. Okay, sure.
Yeah.
So I'll just write, if we when we apply the or logical operator between two, if both the conditions, so this should be different now. If instead of both, one of the conditions is true, then the result will be true. And if, so instead of any one, I'll write both of the conditions are false, then the result of applying the or operator between the two conditions is also false. Okay, sure.
Yeah.
And the third operator is the not operator. So the symbol of the not operator is like this. Okay, so this exclamation mark. So we already saw a bit of this thing when I taught you the not equal to operator. Am I right?
Yeah.
Okay. So now see, one more important point which I will like to inform here is that this AND operator, these AND and OR operators, these are called as the they have a special name in C language, so they are called as the binary operators. So why do we call them the binary, the binary operator? First, tell me, because we apply them between two operands. Okay, sure.
Yeah.
Okay, so the AND operator and OR operator are called as the binary operators because we always apply them between two conditions. Okay, and here when we are talking of logical operators, each condition which is mentioned before or after that logical operator will be an operand for the condition. Okay, sure.
Sorry, what did he say?
No, I said in case when I'm talking of logical operators, that is and
Yeah.
or operator or not operator. So each operand of that operator is one condition. Okay, sure.
Okay.
So this and operator hmm, and or operators are the binary logical operators because they are applied or they are used between two conditions at a time, and hence they are named as binary logical operator. Clear, Shub?
Yeah.
So this point I'll mention it before the not operator. That is the and operator and or. So I'll just write this is and operator, and I'll put a comma here, otherwise you may get confused between this and the word and. The or operator are binary logical operators because they are used between two conditions at a time. Clear, Shub?
Yeah.
Now not operator. The not operator is a unary logical operator because it is used on only one condition. Okay, it is used on only one condition. So since we apply the not operator on only one condition and not between two conditions, not is a unary operator. Is that clear, Shu?
Yeah.
Okay,
Yes.
I'll write the truth table for it now. So truth table will be very easy for this. We'll just have a condition and result of applying the not on that condition. So if the condition is true, obviously the result of applying the not will be false. And if the condition is false, then the result of applying the not on that condition is true. So when we apply the not operator on a condition, it reverses the value returned by the condition. Okay, sure.
Yeah.
Okay, so as I told you that not operator is a unary logical operator, and the and the or operators are binary logical operators. Okay, so let us do a program related to this now. The program related to this is program to accept the percentage, this aggregate percentage, of a student and find the grade of the student, Shubh, as per the percentage. So suppose it is given, this data is already given to us, that if the aggregate percentage is above 85, then grade is A. Okay. If the aggregate percentage is between 75 and 85, one more thing I'll write here, if it is equal to or above 85, then grade is A. If it is between 75 and 85, the grade is B, suppose. Then if the aggregate percentage is between 60 and 75, then we can say grade is C. Then if I won't write the exact words now to save time, it is between uh, 50 and 60, then grade is D. And suppose the aggregate percentage is less than 50, okay, then suppose fail. Okay, sure, clear.
Yeah.
Okay, so what I'll do here now, see, hash include stdio.h int main. Now I'll declare a variable called float percentage. So I'm purposely taking it float because sometimes percentage can contain decimal point also, na? That is 75.8%, whatever. Okay, sure.
Yeah.
Okay, then the printf statement will come. Enter the percentage of the student. So enter percentage. Scanf percent %f and PR. Okay, now first condition, as I told you, what is the first condition? If the percentage is greater than 85, greater than equal to, okay, so greater than equal to, just see this show. So this symbol which I have written here, it is the symbol called greater than or equal to. Okay, so if the value of the PR variable is either greater than 85 or even if it is equal to 85, in both the conditions, in both the cases, PR greater than equal to 85 returns true. So okay, clear.
Yeah.
Then I will display percentage is not percentage, sorry, the grade is A grade as what is given in the problem statement. So I'll just mention one point here, that this operator which I have written above is called as the greater than or equal to operator. Okay, so if the value of the PER variable is either greater than or equal to 85, then PER greater than equal to 85 returns true value. Okay, and obviously if the value of the PR variable is less than 85, then PR greater than equal to 85 returns false value. Clear, Shuk?
Yeah.
Okay. Now see, I'll have to check more condition now. So what I'll do, as of now, I'll mention one more if block. So the condition for the second if block is if the aggregate percentage is between 75 and 85. So when I have a range, I can express the range using the AND operator as follows. See, I can write PR is greater than equal to 75 and PER is less than 85. Am I right, Shu? So this means that the value of the PR variable lies between 75 and 85. Is it clear?
Yeah.
So see, suppose the value of the PR variable is suppose exactly 75. Then what will happen? Then the first condition will be true, and at the same time the second condition also will be true, because 75 is also less than 85. So hence, because both the conditions are true, then the entire if block condition will be true, and the grade will be displayed as B, which is which we will be writing in the body of the second if block. Clear, Shuk?
Yeah.
And similarly, one more thing. If I enter the value of the PR variable as 78, suppose, Then what will happen? Again, this condition is also true because it is greater than 75, and this condition is also true. So again, the grade will be displayed as B show. Okay, so
Yes.
okay, so I'll write a printf statement here. Grade is B. Okay, so I'll make one mention of a small point. In the above if block condition, we have used the AND operator to check sorry, whether the value of the PR variable lies in the range that is greater than or equal to 75 and less than 85 range. Okay, so
Yeah.
okay, and see one more thing. Suppose I enter the percentage as 85, then obviously what will happen? Then this first if block will be executed, not the second if block, because when I enter the percentage as exactly 85, then this condition will be false. Am I right? The second,
Yeah.
because true and false, but the first condition will be true, but second will be false. So because the second condition is false, so the combined condition will be false because we have applied the AND operator.
And
Okay, yes. Now the for the grade C, so I think grade C it was 60 to 75, na? So
the
I'll put 60 here, and I'll put less than equal to, no, not equal to, sorry, less than 75. So now the grade is C. So similarly, what does this mean? If the value of the percentage variable satisfies both the conditions, which two conditions? That it
great
must be either greater than or equal to 60, and at the same time it must be less than 75. That is, it must lie in the range from 62 to 75, where 60 will be included but not 75. Okay, sure. Then
yeah.
entire third if block condition is true and the grade will be displayed as C then. Okay, similarly we'll have one more condition now, that is from 50 to 60. So this is 50 and this will be less than 60, na? So
Yeah.
okay, because if it is equal to 60, we are displaying the grade as C. Then the grade will be D. Now, finally, we'll need only one condition now. That is, if the percentage is less than 50, then the grade is or fail. You can put. Okay, so clear?
Yeah.
Okay, so
Uh,
yes, I know what you may want to ask me. That here we can use one more block called if else if block, na? So
uh, can we not use else block to write
yes, yes.
that?
No, no. That what you are asking me, that's what I'm going to write in explain you. I will
Okay.
make one more copy of this program as program number 3, and in that I'll use the if else if blocks now. Okay, so
Okay.
see, first of all, as you asked me, this code will give us the whatever program I have written will give me the proper answer. It will give me the
Okay.
correct answer. But
So
unfortunately, the 1 minute, let me finish. So, but unfortunately, this code is not efficient. Show, okay. So why is it not efficient? Tell me. See, suppose I enter the value of the PR variable as 85 or more, then the condition of the first if block is true. So it will execute the first if block body, that is the grade is displayed as A. But again, the C compiler, what will it do? It will come down and it will check the conditions of all the remaining if blocks also. Am I right? Sure.
yeah.
So here, what is happening is that though we are getting the correct answer, but because the if block is checking the conditions of the unnecessary if sorry, because the compiler is checking the conditions of the unnecessary if blocks, so hence we are wasting a lot of execution time. Show, is that clear?
Yeah.
So here, once the grade is displayed as 80, grade is displayed as A, if the value of percentage variable is greater than or equal to 85, then the C compiler must not check the other conditions, because that will be a waste of time. Okay, because see, for example, if not only the program, suppose not only a C compiler, uh, suppose someone is finding in the aggregate percentages based on the average total of each student, and suppose along means as per the aggregate percentage, the students have been allocated a grade just like they have given in this program. So obviously once the grade is proved to be A for a student, that same that person who has been told to who fill in the grades or whatever, he will not check if the that aggregate percentage lies in the other range issue. Okay, because that will
Yeah.
waste a lot of time of his, obviously, and there's no need for that. So but here what is happening, since our compiler is not human, so obviously because we have not used the appropriate code here, and here I have mentioned only independent if blocks. So here, even if a particular if block condition is true also, what will happen, the compiler will still check the conditions of the remaining if blocks also, and this will waste a lot of execution time, though we get the correct answer. Have you understood, Shub?
Yes. So I just wanted to ask. So
Yes, yes, you
it's
can
not,
ask.
not necessary to have an else statement. We can only write an if statement.
Yes. See, as I told you in the previous example which I had given you, I'll open the program if you want. 1 minute, or it's here only. It looks like 1 minute. I think it must be here. 1 minute. I'll just open the previous program. So see, we don't need to have an else block compulsorily. Following is if block, but obviously for getting the proper output, we use an else block also. Otherwise, what will happen is that suppose the if block condition is false, then it will not execute anything. So suppose I entered the number as odd, and since we have displayed that the number is odd inside the else block, so if we remove the else block and if we enter an odd number, then what will happen? Then we will not get any output on the screen. Sure. Okay.
Oh,
Okay, so see, if I remove the else block from here, for example, then I will not get an error. But then what will happen? That only when I enter even numbers, I will get the output as that the number is even.
okay.
But if I enter odd number, then because this condition is false, this body will not be executed. And because we don't have an else block, so nothing else will be displayed on the screen. And so you will not get any output on the screen for odd value. Okay, so to make a program, obviously to satisfy the needs of our program and get the output accordingly, we use the else block also. But syntax
Okay.
wise, even after an if block, if I don't write else block, I will not get a compiler. Clear, sure?
Yeah.
Okay, so if you want this point, I can write in the theory part where I've written that if I want, I can write it here only. It is not compulsory to write an else block after the if block, but in that case, suppose the condition of the if block is false, then because the body of the if block is not executed in that case, so we may not get any output on the screen if we enter, or if in case our if block condition is false. Clear, Shub? Okay, clear? Hello?
Yeah. Yes.
Okay, so I'll close this. Let us continue with this program. So I'll just write that what problem we'll be having in this program, though, which I explained to you now. So here we will definitely get the proper correct output for the above program. But in the above program, because we have mentioned independent if blocks, so in case a particular if block condition is true, still the C compiler checks the conditions of the remaining if blocks also. This will unnecessarily waste the execution time. So example, suppose the percentage of the student is accepted from the user as 87, then the first if block condition will itself be true.
Yes.
So then the body of the first if block is executed and the grade is displayed in that case as A, but still the C compiler checks the conditions of the remaining should else blocks, if blocks,
If not.
and this will waste the execution time unnecessarily should, as you told me. Am I right?
Yeah.
Okay. So what we'll do now, I'll first of all run this program and we'll create one more version of this program which is a more efficient version now, where I'll be using if else if now, and at the end I'll use else block. Okay, so let me first see whether I'm getting this output correctly or not. So most probably I'll get the output. Let us confirm once. So if I enter percentage 78, grade is B. If I enter the percentage 85, then the grade must come as A. Okay, so
Yeah.
enter the percentage exactly 75, again it's B, I think, na? For 75.
Yeah.
Yes, so we are getting the output. You can check for the other values also. We'll definitely get the output. Now, as I told you that I'll save it as program 3.c. Here I will first of all remove these comments which I had written in between, because these you already know now, and these are there in the previous program. I'll put else if here. Sure, okay. Else if, again here I put else if, again here I put else if, and at the end I put else should. Okay, sure.
Yeah.
Now see, now how will this work? So I'll put one very important point in front of you now. Key, here we have written one if block. If you notice, we have written one if block and multiple else if blocks, and the last block is our else block. So here every else if block is associated with the previous block, with the block previous to it, whether it is an if block or a else if block. So for example, this else if block will be associated with this if block. This else if block is also will be associated with this else if block, and so on. Now, if the condition of the first if block, that is percentage greater than equal to 85, if it is true should, then what will happen? The grade is
Okay.
displayed as
Yeah.
A automatically, and now because the condition of the first if block itself was true, the compiler will not even check the conditions of the remaining else if blocks. Clear, Shub? Okay, it
Yeah.
will directly skip the whole else if. It means see, in the previous case also what was happening, that if the condition of the first if block was true, then the other else if blocks were not executed. But in the previous example, because we had put only if blocks, so at least the compiler, even if it was not executing those remaining if blocks, but still it used to waste unnecessary time in checking their conditions. Okay, sure.
Yeah.
So here what is happening? See, in case the condition of the first if block is true and the percentage is entered as suppose greater than equal to 85, then the condition of the first if block will be true, the grade is displayed as A, and now the C compiler will directly skip all this else if block, which means it will not even check the conditions of these remaining else if blocks. Okay, and even the last else block will be skipped automatically. So here, though we are getting the same output as the previous program, and though both the programs are giving us the same output, but this program will be more efficient. Show, okay, Show.
Yeah.
See, suppose the condition of the first if block is false, then only the control comes to the second else if block, or to the first else if block rather, I should say, because this is the first else if block in among the remaining else if blocks. Am I right?
Yeah.
So, as I told you
Yes.
that in case the condition of the first if block is false, then the control comes to the else if block after it, and then only in that case the compiler will check the condition of this else if block. Now, if the condition of this else if block is true, which means if the percentage lies between 75 and 85, then the grade is displayed as B, and the compiler will not even check the conditions of the remaining else if blocks after it. Okay, okay, sure.
Yes.
Okay, and even the last else block will be skipped obviously. So we can say in this program that the control will come to a particular else if block and will check the condition of that particular else if block only if, very important, only if the conditions of all the if blocks and else if blocks prior to it were false. Okay, so
Yeah.
which means When will the compiler come to this else if block and check the condition of this else if block? Tell me, which I highlighted. Only in
Um,
case the condition of the first if block and the this else if second, these two else if blocks are false. Okay, sure.
false. Yes.
And and now obviously when will the last else block be executed, or when will
Well,
the else block mentioned at the end be executed? Only when the conditions of the first if and all the remaining else if blocks after it were false. Only then this else block will be executed. Is it clear, so?
yes.
Okay, so I'll mention that point here now. Key. Uh, Suppose the condition of the first if block is false, is true, sorry. Then the body of the first if block is executed and the grade is displayed as A. Now, the C compiler will not even check the conditions of the else if blocks after it, and all the else if blocks after the first if block, and obviously the last else block also, the last else block, are all skipped without even the compiler wasting time in checking their conditions. Is it clear, Shubh?
Yes.
Then, as I told you, only in case the condition of the first if block is false, then the control comes down to the else if block after it, and only then the C compiler checks the condition that whether the value of the PER variable lies between the 75 and 85 values for the else if block which is after the first if block. Clear, Shu?
Yeah.
So this means that in the above if else if dot 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 up till else structure, every time the C compiler will come to a particular else if block in the above structure or code and check the condition of the else if block only in case the conditions or condition of the first if block and all the remaining, or instead of remaining I'll just write and all the else if blocks till the current else if block are false. Am I right?
Yes.
So for example, the compiler will check the condition that is PER greater than equal to 60, suppose we said, and PR less than 75 of the second else if block only in case the condition of the first if block and the else if block after it were false. Understood?
Yes.
So this saves a lot of execution time by the compiler, and the compiler will not waste time in checking the unnecessary conditions, unlike in the previous example where we used only if block. Though both the programs, that is and 3, give us the same output. Clear, Shubh?
Yeah.
But as I told you, the program number 3 is more efficient because, as I told you, its execution time will be lesser, will be saved. And so the and why is that? Because the unnecessary conditions are not checked. Is it clear, Shubh? Shubh, clear?
Yes.
Okay, one more point I'll add here. As I told you that the last else block in the above structure is executed only in case the conditions of the first if and the remaining else if blocks were false. Okay, so I hope everything is clear, Shub. Okay.
Yes.
Okay, so I don't think I will need to again run this program. Okay, because we'll get the same output as the previous program. Don't worry. Okay, and see here, though I say that we are saving execution time, but it will hard in this case at least it will hardly save nanoseconds of time. So you will not come to know in the output that how much time we have saved and so on. Okay, but obviously this when you use the if else if code, it definitely saves a lot of time. Have you understood, Shub?
Yes.
So what I'll do, I'll stop for today. Okay, so I'll just do a small revision of which concepts we learned today. Today I taught you about the if-else block, and then I taught you regarding the three logical operators, out of which the AND operator and OR operator are the binary logical operators, and the NOT operator is a unary logical operator. Then we saw what is the is equal to or the equality comparison operator and the not equal to operator, and then we saw this new type of structure called if else if structure. Okay, so I hope everything is clear, Shub, today.
Yes. Yes.
You had some doubts regarding the homework you were saying, na?
Yeah, I had doubt regarding one of the programs.
Okay, which one was that? I'll open the folder if you want. Okay, it was in the homework assignment list, was it?
Yeah.
Okay.
Last one, I think, question 8. Uh,
Okay, question 9 or 8 was it?
8.
8.
Yeah.
Huh. Okay.
Yeah, I think it, it it was just calculating that, but it kind of didn't make sense because the
Yes.
net salary was greater than the gross salary.
No. The gross salary must be greater than the net salary. No? Because I have see what I have done. I've mentioned the formula also here. That net salary is equal to basic salary plus HRA plus DA, and gross salary is equal to net salary plus PF. Means whatever value I get
So is
for
the
net
HR
salary. Yes. Yes. Tell me.
is HRA and DA taken out or added to the basic salary?
So already I mentioned it here. Na? See, HRA is the house rent allowance. That is, it is 10% of the basic salary. So when you write the program, so you must first accept the basic salary from the user. Okay,
Yes.
and after accepting the basic salary, then according to the basic salary, we'll calculate the value of HRA and DA. That is, HRA is 10% of basic salary, which is basic salary into zero point 0.1, and the
Yeah.
DA will be 25%. That is the basic salary into 0.25. Understood, Shub? And then when you
Yeah.
get the values of HRA DA, then you can calculate the net salary using this formula which I have already given. And you then using the value of net salary, you can calculate the gross salary, Shub. Okay, Shub?
Yeah. So wouldn't the uh,
Yes.
okay, yeah.
Okay, clear, na? Shub?
Yeah.
So and also see PF means provident fund. Okay, so already I have told
Yeah.
that PF is fixed to rupees 2000. So which means that you can declare or define rather a PF as a constant, Shub, using the hash define command. Okay, clear, na?
Oh yes. Oh yeah, I did that. Yeah.
Okay. And also one more hint I'll give you, that in this program you can declare all the variables to be float type, because obviously you will get the values for HRA DA as float, na? Sure. Okay. And since the
Yeah.
salary he can also be expressed as a float value, means in terms of rupees and paise. Okay. Okay, so is it clear, Shub?
Yeah. Yes.
Okay, so just try out this program once again, and if you have any more queries you can ask me tomorrow. Okay.
Yeah.
Okay, Shub. So what we will do now, we'll stop for today, and tomorrow we will again continue at 12 o'clock, and we'll finish off the remaining programs of this if else chapter. And I will give you the homework assignments of if else tomorrow after we finish this topic. Okay.
Yeah.
Okay. ठीक. Okay, Shub. Then whatever I've taught you, I'll send you an email now. Is that fine?
Yes.
Okay. Okay, Shub. Okay. Yes. Bye. Okay.
Thank you.
Yes.